this lesson is about a binomial probability. So in a binomial experiment, there's three things. One, the situation involves repeated trials, so more than one trial. Two, each trial has two possible outcomes, success or failure. And three, the probability of success is constant throughout the trial, so the probability doesn't change and the trials are independent. So binomial probability, suppose you have repeated independent trials, each with a probability of success P and a failure of Q. So the success and failure have to add up to 1. So there wouldn't be like 3 different options. There need to be 2 options, success and failure. Then the probability of X successes in N trials is using a formula where there are N trials, choose, or combinations, X successes, and then P, so P is the probability there's a success, so that's going to be a fraction or a decimal, 1 or less, raised to the X power, where X is the number of successes, times Q, where Q is the probability of failing, and this power is going to be N minus X. So these are all multiplied, so this is a number that you're going to multiply by this, and you're going to multiply by this. So you're multiplying now, this P is going to be a fraction less than or equal to 1, at least 0. This is going to be a fraction that's at least 0, no more than 1. And these exponents are going to add up to the number of trials. So first example, a fast food restaurant is attaching price cards for every one of its soft drink cups. The restaurant awards free drinks as prizes on 3 out of 4 cards. Suppose you have 3 cards. Find the probability that exactly one of these cards will reveal a prize. So this tree diagram visualizes what's going on with this probability. So what's the probability you get all 3 prizes? So there's one path of success right here, and it's going to be 3/4 to the, and you're going to get 3 cards, so 3/4 to the 3rd power. So 1 times 3/4 to the 3rd power. Now you could follow this formula and put the probability of losing is 1/4 to the 0 power. So 1/4 to the 0 power is just 1, so that's kind of why it's not listed right here, because it just cancels out. Same thing with down here. So the probability this person loses is 3/4 to the 0 power. Or probability that person wins is 3/4 to the 0 power and 1. That's why it's not listed. So in front of here, there's 3 different ways that you can win. So the coefficient here is 3, 3, and there's 1 possibility right here. I'm just following the tree diagram here. There are 1, 2, 3, 4, 5, 6, 7, 8 different outcomes that you can have. So in all 3, these all add up to 8. See? So this is 1, 3, 3, 1. They add up to 8 because there are 8 branches or 8 roots at the end of our tree diagram. So the probability that the person wins 2 prizes is 3, because you can see from the tree diagram that I have 3 branches that are coming, that they win exactly 2 prizes. See, 2 P's, 2 P's right here, and 2 P's right there. And the probability that they're going to win is 3/4. If they win 2 times, this is going to be a power of 2, and then they're going to lose 1 time. And then down here, the probability that they win 1 prize is they win once and they lose twice. And the probability they don't win any prizes is they win 0 and they lose 3 times. So if you calculate all of these will all add up to 1, these different scenarios. So the key thing is, what you can do is, you're not always going to make a tree diagram. What you do is use combinations. So if there are n trials and you have a success x times, this is what you're going to put that number, n choose x, in front. And you can use your calculator if you want. So number 2, Alicia walks to school with their friend Juana. Juana is on time 80% of the time. What is the probability that Juana will be on time 5 days in a row? So we're talking a total number of 5 days. So I'm going to do 5, choose. How many of those 5 days is she on time? So it's 5, choose 5. So then this is the number of successes. So then I'm going to multiply it by the probability of success, which is 80%, and raise it to the number of times it's a success, or how many times she's on time in those 5 days, which is 5. And then I'm going to multiply by the probability that she's not on time, which is 0.2, and the number of times that she's not on time in that situation would be 0. So what you do is, in your calculator, you calculate 5 choose 5, which happens to be 1, and then you do 0.8 to the 5th power. So I'm going to do 0.8 to the 5th power, and that is 0.32768. So that is about 33% chance. Number 3, find the probability of x successes and n trials for the given probability. So you're going to have 5 total trials, and 2 are going to be successful. The probability that you are successful is 0.25, and you want to be successful in 2 of those. And the probability that you're not a success has to be 0.75, and then the number of trials that are left is 3. So you're going to calculate 5c2 times 0.25 squared times 0.75 cubed. So I'm going to do that in my calculator right now. So that is approximately 0.26. Approximately. The next one, there's going to be 10 trials, and the probability of success exactly 8 times. And then the probability that is a success is 0.7, so we want that to be to the 8th power. And then 0.7, if you're successful, then 0.3, you're not successful, and the number of trials that are left is 2. So again, you can just calculate that on your calculator. Okay, number 4, when it rains, there is a 70% chance that soccer practice will be canceled. If it rains for the next 3 days, what is the probability the practice will be canceled at least one of the days? So the tricky words here, and it's underlined, at least one. So we got to look at the probability of 1, 2, and 3 days of it being canceled. So I'm going to do it kind of a longer way, and then I could show you how to do it maybe a shorter way. So we have 3 days. So it's going to be 3, choose 1, because this is going to be it's canceled at least one day. So the probability that it cancels to the 1st power times the probability it doesn't cancel to the 2nd power. Plus, you got to account for what if it's canceled 2 days. So this is going to be, of the 3 days, it cancels 2, 0.7 to the 2, and then 0.3 to the 1. Plus, now it could cancel all 3 days. So this is going to be 0.7 to the 3, and then 0.3 to the 0. Actually, I'll just do it, keep it this way. So this first one represents it's canceling 1 day. So there's 1 success, 2 failures. This one represents it's canceling 2 days. 2 successes, 1 failure. And this one represents it's canceling 3 days. 3 successes, no failures. So I'm going to put this all in my calculator. So when I get that in my calculator, it's approximately 0.973. So there's about 97% chance that it's going to cancel at least one of those 3 days.